Hello everyone. This video is about how OKE can be used in order to deploy LLaMA 70B lean model and on A100 GPUs, and then what exactly we are doing in order to create the cluster of A100 GPUs with the help of array and vLLM. So yeah, I will start by showing the nodes, how to access them. So here there are 4 nodes and they are assigned with the private IPs. And the information about each and every node is provided here. So before accessing this node with public IPs, let's see whether we are able to access the nodes or not. As I mentioned, I already provided the the Kubernetes support. So I'll simply check whether the nodes are being identified or not. So you can see all the IPs and the nodes are being identified, which I already mentioned from this particular node pool. And then let's see, do we have any pods already there? In the default namespace. So these are the pods which are already running and some of the pending pods. So before accessing the pods or before deploying the pods, I'll simply go through one of the nodes just to check what are the configurations. If I want to make some changes, I have to mount some of the directories or not. So these are the things I need to make sure. So for that, let's see the provide the IP, and then the Oracle Linux is something I have provided. And then I will go one of the nodes first, but I need to have the public IPs and then let you know what exactly I'm looking for inside this particular node. So I'm inside the node, which is a node from the cluster node pool. And let's see, first thing is the NVIDIA GPU, which is A100, and then we do have this CUDA version 12.6. So this is fine. This is one of the VM machine, virtual machine from the A100 instance. And let's see how much size we do have on this particular. So we have this kind of a memory, but we want to increase the size of the cluster, size of the memory inside the node. So for that, we have to run some command, otherwise we'll face the size limitations. So I'll see how exactly we can do this particular task. So this is the command in order to grow the size of the volume. And then let's confirm whether it is done or not. So yeah, we have already extended to 3 terabytes. So this has to be made clear. This has to be provided while creating the node pool. There you have to mention that, okay, we need this much amount of space. Although it may not be required, but this is only for clarification. Like if you are installing something, some of the local files are installed or cached here. So this space will be limited. And then you will face some difficulties in future in order to perform some operations. So the next task is to perform the similar operation on the other three nodes. I have done it already for you guys. So you can see the memory is already extended to 3 terabyte, and the node is basically A100 GPU, the virtual machine, and the same thing is here as well. And then you can see the node type also A100 GPU, and the same is applicable here, where you can see the memory size has been extended, and you can check the node configuration, which is NVIDIA A100 GPU. Now our next task is basically to mount the shared file system, so that particular shared file system will be visible to all these 4 nodes. And then whatever we want to perform, for example, if you want to deploy LLaMA 70 billion parameters model on these 4 nodes, it should be easier because we don't need to make a copy of that particular data on each and every node. These nodes will take the data from that particular configuration, like from that particular shared file system. So I already mounted it, that particular shared file system. If we are going somewhere here, so storage, and then we have to create the file system, but I have already created, and then I'll I do have this file system, and then for that there are two mounting points. So I'll mostly be going through this particular mounting point. So they have the mounting commands. When we go there, you have to install and then make a directory which is a mounting point, and then you have to mount it. So I'll go into that particular details, how exactly we are doing it. And then, so first we have to install. I'm going in one of the nodes. And then once the installation is done, now we can create a directory for the mounting point. Once the mounting point directory is there, and then we can mount the directory. Let's see if that particular shared mount system is already there or not. Yes, it does have, and the data that we are discussing is somewhere available here. It's available somewhere here. You can see I do have all the information about the models. I have already copied it or downloaded it just for the simplicity. So I have created the shared mount system and then deployed it in each and every node. So I have already done that process, and then you can see the .cache file is already there, and the shared file, if you see, is mounted somewhere here. And the same is applicable on this node also, and then here also. But remember, whenever you are mounting this particular shared file system and this particular node, when you are creating a node pool, they have to be on the same VCN. Otherwise, you will not be able to mount them. So for example, here, if you see, this is my mount target, and the information corresponding to this is OKE KAD, and this OKE VCN. So this is the same VCN I'm talking about for the subnet and the VCN virtual cloudnet, which I have created for the node pools also. So that has to be taken care of. So, well, until now we have done the creation of the cluster, addition of the node pool, which is A100 node pool, and then we have created a shared file system and then mounted on each every node. And before that, we have increased the space for each and every node. Now our next task is just to check the nodes. Again, I will mention the nodes are ready or not, and then deploy some of the pods, create the namespace, and how exactly we are deploying the LLaMA 70B. And also for that, what are the initial things we are taking care of. So as we know, for A100 and also LLaMA 70 billion parameters, we need around 140 gigabytes. Each and every A100 has only around 80 gigabytes of memory, you can see, which is around 82 gigabytes of memory. So 140 for 70 billion parameters is not enough. So that's why we need to create a cluster, which we call it as the array cluster. And then this link will be following in order to create a array cluster. The reason is a model cannot be, this particular model cannot be completely deployed on a single node. We need the combination of nodes in order to deploy the model. So hence we have to create an array cluster. So this particular link I'll be following up. So in order to do that, we already need to mount the directory, and then I'll show you. I'm already inside a folder where I'm having the several files, and before that I need to mount my persistent volume, which is the FSS directory in this particular volume. So the details I have already provided. I have taken the help online how exactly you have to create. I have provided the server IP and the mount directory, and where exactly it is mounting, that will be shown in the final file, but the name will be given like persistent volume. And then finally, I need to have one more persistent volume claim file. So this is not required, but this will be basically taking the storage FSS and the persistent volume PV. So the requirement for this is the persistent volume PV and the FSS, which is the storage class name. So if you see, both the files are already here. One is the persistent volume, which is also dependent on the storage. I mean, we have to provide the storage, and there is the storage file class.yml. So let's see what exactly inside this particular storage class.yml. Here I have provided the mount target. So the mount target I was showing, so you can get the information from this OCID, whatever the mount target you have for this particular mount target. And then you do need to provide this particular target, and then it will be well and clear. So let's launch it one by one, step by step. So first we have to create a namespace environment. So let's follow this particular line here. I have to check whether it is already added or not. Let's see. Already exists. So I don't need to update. This is already there. Let's see. We will install this particular Kubernetes operator. If it is false, we cannot reuse a name that is still in use. It is already there. That's why it is not possible to use this particular namespace. So what I will do, I'll delete this particular namespace. So let's remove this first and then reinstall again. So this Kubernetes operator names, I will say the operator basically, sorry, is uninstalled. Now we need to reinstall. Let's see. So this is done. So let's see the pods inside this particular namespace. It will ask for the namespace also if it is not created. It was already there, so that's why there is no problem. Let's see until we get this is running and ready. Still pending. I need to describe the pod. So here also we have to be sure what are the problems. Describe pod while deploying this particular onto a GPU, and then we have to provide the namespace also. You can see there is a taint available on this particular GPU which we have to remove. So for that we need to follow some command in order to remove the taint from this particular node. So how to do that? There are again the commands available in order to remove the taint. I'll simply mention it here or copy it here in order to remove the taint. So let's see which are our nodes again. So these are the private IPs. You can see 166, 82, 95, and 99. So in order to remove the taint, I have this particular command. So I have provided the IP 166, and this is for removing. And last, the hyphen symbol. 166 is there, and 95 is there, 82 is there, or 99 is there. Okay, let's see if they all are removed or not. Untainted. Okay, all of the nodes with NVIDIA GPU are untainted. Let's see the pod description again. Okay, it is successfully assigned Kubernetes operator. Let's see if it is running or not, or still pending. This particular pod. Container is creating. It takes slightly some time. Started container. Now it should be up and running. You can see we have achieved this particular phase now where the operator is running. Now we want to deploy a Kubernetes cluster. But before that, we also need to check whether the PVC has been mounted or not. I think we have already done that. No, not yet. We have to create the deployment for the storage and the POC volume so that it is visible. So I'll again run those particular commands in order to deploy each and every PVC, which is a mounting point for the persistent volume claim. So first, for the storage class, we need to check. Okay, I have already done that, so that's why it is unchanged. So that's the first command. Then we have to do it for the volume. It is also configured. And then let's check for the persistent volume claim. If there is any problem, we have to check the pods also. It is also unchanged. Now let's see all the pods or the PVC, basically the persistent volume claim, whether it is running or not. If there is any problem, we will get to know about it. Okay, it seems it is perfectly fine. There are no problems. And the same thing we can do also for the PV, which is only persistent volume, not the claim. This seems to be okay. This retain, and then yeah. So now we have the persistent volume claim, which is already deployed. Now it's time to deploy a Kubernetes cluster, which I have the basically array cluster. I have a slight modification because I'm also deploying the volume, and then there is a mounting path also, which we have to provide. So let's see what exactly that file looks like. So this is not required. We need array cluster. Most of the file is more or less similar. The only thing is I'm choosing this particular array ML instead of this. It seems this is not available. If it is available, it will take directly. Here also it is the same. And what I'm doing, I have 4 nodes. So one I'm creating as a head node, which is provided here, and the another 3 are going as a worker nodes. So I'm giving simply the same 3 nodes everywhere, and then it will create one as a head, which is a master node, and another 3 as a server nodes. Okay, here the mounting won't happen, just like for creating a cluster I'm showing. Namespace name. It has been created. Let's see if we have the parts or not. Yeah, you can see first the operator, and the second thing is the head node, which is given by this, and the worker nodes, remaining 3 as the worker nodes. So all of them are having a GPU A100. So I will get inside one particular node, let's see head node, and then describe this particular head node, in which phase it is, whether it is downloading or not, and that particular container image. And describe. It should be a pod. I'll remove that. Describe pod. Yeah, it's still pulling the image. Let's see for the other pods also, what exactly they're doing. Okay. So the worker nodes or the worker pods are also pulling the particular image. So let's wait until this is done. So now you can see all the pods are up and running, the head and the worker. How exactly each and every pod looks like. So this is a worker pod. I'm just describing it. So initially it was at the pulling stage, but right now it has already started the container. So here the same thing is happening with the head node also. So that's a head node. And then if we describe, so this is also the started the container. So all the 4 pods already deployed for each and every node, which each node having one A100 GPU, and we need this particular operator. So like this, we have already deployed. Let's go inside this particular cluster, and then let's check whether the array is running or not, and we do have a cluster or not. So the command for that, in order to check the array cluster, is given by we need to execute this, and then we have to provide one of the pods. Let's choose the head pod. And then once we have chosen the head pod, I'll simply provide the namespace, and we have to go inside this particular pod. I'll simply write the bash. So you can see we are inside this particular environment, and let's check the status of the cluster. This is how we can check. So you can have a look. There are 4 GPUs, 4 CPUs, this much amount of memory we have already provided, and 4 nodes. So these are the details which I wanted to mention. Here I haven't mounted any shared file system. I will show you in some time what exactly is happening. But yeah, apart from that, you can also expose the array dashboard using ingress. For that only I have created that ingress command. So this is how you can check. I'll not right now go into that particular details. First, I will go with the vLLM library, which is necessary in order to deploy the workload, which is the LLaMA 70 billion parameters onto the 4 A100 nodes. So let's exit from this particular system, from this particular environment. This is how we have created the cluster. And then let's check the pods again. They're running. We have to remove or delete all these particular pods. So in order to delete all the pods, not the Kubernetes operator, so we can do one thing. We can give the name step by step. Well, let's see. Let's start from the scratch. Let's delete everything. From this particular namespace. So all the pods are deleted. Let's check the pods inside the Kubernetes system. That's still running. That's surprising. So let's do one thing. Let's remove the deployment, and that will be remove get deployment first inside the Kubernetes system. So there is this Kubernetes operator deployed, and then I'll remove this particular deployment. So for that, we simply need to go inside this particular deployment and delete it. If we don't delete it, what will happen? Because the GPUs are already occupied by this particular pods, so it will not release the GPUs, and the pods will have the resources, and we cannot deploy the other container image. Let's see the pods also. Okay, now let's remove all these pods again. Sorry for that. Now these should be deleted. Okay, there are no pods into that particular namespace. Now let's follow again this particular deployment. and let's see. So we have to perform this particular command, but again the kubro operator is already there, so first we have to uninstall that operator. So I'm uninstalling it. Okay. Then I will restart everything again. Okay, this particular command, which is kubro operator. The next will be, I'll simply check the pods, the operator is running or not. Yes, the operator is already running. And then we have to deploy a kubro cluster. So instead of this, now what we will do, we will deploy a vLLM on top of a Ray cluster. So let's see how exactly that YML file looks like. So this is the file. Again, you will find this particular file online. And then I'm providing the CPU type A100, but these are again GPUs. So the actual GPUs are provided here. I have just given some names, so you can change those names. I have provided the persistent volume claim somewhere here. And then this is the exact library. This is the exact container image. We can also take the latest image, no worries about it. We can change it. And here I'm providing the GPU configurations. So one on the head node, again the same, and the replicas are 3 for the worker nodes. And then here also I'm providing the PVC, which is the persistent volume claim. And the same, the container image, post one, we can change it to the updated one. I'm keeping it as it is for now. So we have to run this particular command, and where exactly we are mounting, our mounting path is here, data model. So we'll check that. This is the mounting path for the shared file system. So what we have to do, we simply need to run it and then check the pods. So again, 1 for the head and 3 for the worker pods. Sample created. Let's see the pods inside. So it seems this head from the previous is already running. They are not yet deleted again because it is again launching it in the background. So what we can do, we can delete them again. Because they're not deleted, then the resources will not be allocated to the new pods for the vLLM container image. So one of the head pods got the image, but not the other 3. Right now I don't want to delete all the pods, simply the one from the previous deployment. So this one I don't want, I need this operator. I want to delete this. I might be doing something incorrect, that's why the deleted pods are also coming again. So this I have to check, but nevertheless, we can check this. The idea is basically the resources should be made available for the new pods which we are creating for the vLLM container. Somehow to delete the old pods. Let's see the new pods now. So you can see the pod is initializing. Other 4 pods already running. Let's see the condition of this particular pod, and then describe. This also started the container, array container. And then this is the image which you have pulled. Let's see all the pods again. Perfectly fine. So all 4 of the 5 pods are running. One is basically for the query operator, another 4, one is for the head, and the 3 for the worker pods. Let's get inside the one particular pod. Let's see head and then check the array cluster and the vLLM library, whether we have it installed or not. I'll simply take one of the node, which we call it as a head, and then get inside the environment. So we are inside the environment, and this is the working environment. And let's see. First, and then what we have to check, we have to mention about the array status, whether we do have the cluster or not. You can see there is a cluster, 4 GPUs. This is CPU only. We have given another name. Accelerator type CPU, accelerator type A100, if we want to choose by this particular nomenclature. But there is a cluster with 4 nodes. And now let's see the mounting points. What we have seen, it was somewhere here, data models, and then a demo one. So this we have already shown. Here it is mounted already, and then you can check. Let's go into that particular directory, models, demo one, and then so we are in the working directory where we do have the model, which is a 70B model. And then we have this particular file in order to deploy the workload and the array cluster. Let's see how we can deploy it now. So what we can do, initially we'll check. I have already downloaded, because downloading from the Hugging Face takes a lot of time. And then this model is already there. Otherwise, you have to provide the Hugging Face. You have to request the access to this particular meta models, the LLaMA models, and then you have to provide the Hugging Face login credentials, and then you can download. But here I have already provided. So let's see this particular file. We do have the cluster, and then on this particular node, as I mentioned, is taking the NVIDIA as my command, and then this is also A100. But as a cluster, we can see it's taking the 4 nodes. So again, we have this file, and then this file also you can check online. This is on the vLLM library. Some of the examples that is provided. I have made some changes inside this particular thing. This is not required, some of the things there. So I have provided the sampling params, what exactly I need, tokens, tensor parallel size, because I want to distribute the workload on 4 nodes. Number of instances, I need only 1 replica, I don't need multiple replicas, the way we do for the training. The directory for the model, where exactly the model path is, and the maximum model length, what exactly I'm providing. So I will tell you why exactly this is important. So initially I'm launching on all 4 nodes, and then I'll tell you what exactly we have to do in order to launch on the 2 nodes. So remember, this is important, because what happens, model loading takes a lot of time, and then what a vLLM or array gives the timeout error, because it is not happening within that particular time window. It goes. And also, when we launch on the 2 nodes, the memory is not enough. So we have to reduce this maximum model length, which we have provided here as a 64,000. This has to be reduced to around 6,000. Whatever number you get, it got reduced, then you have to reduce this particular size. So let's start with that particular thing only. If it is possible on the 2 nodes, 4 nodes, it will not be a difficult part. So let's try to do it on the 2 nodes, and then I will reduce it to, let's say, 4,000, because it will not take the complete model length. Or I have already provided 6,720. So I will simply give 6,000 for now. Then let's run it. So the has taken the data already for the execution. I have not mentioned because but I already saved the data also in order to execute, and then it will show where exactly it is deploying.